Hi everybody, I'm David Peacock in Geometry. Bites. So today we're going to be talking about the law of sines and cosines. Let's start with the law of sines. But first, I want you to take a moment and open a calculator. It can be on your phone or anywhere else. Obviously, don't do that if you're watching the video on your phone, because then you won't see the beautiful images that we have right here, this gigantic white space. Now, make sure that your phone is on degree mode. And then put in the sine of 137 degrees. Now you might be going, Mr. Peacock, how can we go over 90? And that's actually kind of the point of today. You should have gotten about 68, about 0.68. So, and here's a fun fact for you. This is actually also the sine of 43 degrees, which, by the way, is 47 degrees away from 90, just like 137. Interesting. Also, fun fact, that actually was not fun, as it was about, well, math. So now let's try the same thing, but with cosine and then with tangent. So cosine of 137, then tangent of 137. Now, the cosine of 137 degrees is approximately negative 0.73. The tangent is approximately negative 0.93. Now, here's the interesting fact about that. The cosine and tangent of 43 degrees, which once again is 47 away from 90, is the positive version of each of those numbers. So the cosine of 43 degrees is 0.73, and the tangent is 0.93, positive both times. So now that we've established that a piece of information, that we can do sine and cosine and tangent and over 90 degrees, let's now go into the law of sines. So this right here is an obtuse triangle named A, B, C. Easy as 1, 2, 3. Now each side will actually be named after the opposite angle. So for instance, side A is opposite angle A. Side B is opposite angle B. Side C is opposite angle C. We're not really going to deal with side C right now, just really A and B. So now we're going to add an altitude, and the easiest and most obvious altitude to do is H. So there we go. Now, if I wanted to find the sine of A, the sine of A would be equal to H over B, opposite over hypotenuse. And the sine of B would be H over A. Now here's the thing. If I wanted to solve for H on each of these, I would multiply sine of A is equal to H over B. I'd multiply both sides by B. And for the other one, I would multiply both sides by A. So I would end up getting that H is equal to B times the sine of A, but also H is equal to A times the sine of B. And since both of these are equal to H, that means, based off of transitive, that both of them are equal to each other. So B sine of A is equal to A sine of B. Now, I want to get things a little bit differently. So if I wanted to take out the B on the sine of A side, I would divide by B. If I wanted to take out the A on the sine of B side, I would divide by A. Meaning, the sine of A over A is equal to the sine of B over B. And that gets us to the actual law of sines. The sine of A over A is equal to the sine of B over B is equal to the sine of C over C. So there we go. Now that I've established the law of sines, let's see when we can and cannot use it in this brand new game I'm going to call Can You Use the Law of Sines? I'm sure it's going to get picked up by all the networks. We'll go for years in syndication. So let's start with this one. In this one, we are out to find the measure of angle B. So in this case, what we actually know is we know that the side opposite C is 20, and then the angle is 101. and the side opposite B is 14, and we don't know the angle. So we would write that as the sine of B over 14 is the sine of 101 over 20. At which point we could solve this. We just have to multiply both sides by 14 and then do arc sines. So yes, this one would work. So great. Now let's ask about another one. So in this case, we have MN. We are looking for this side. So we could say the sine of 77 over MN is equal to, but here's the problem. No matter which side I do, because I'm going to write it both ways, I end up getting at least another variable. I can't solve for that because I would have one side that's all variables and one side that's all numbers. It would be oops, all variables. So no, I cannot use the law of sines in this case. All right, let's try this one. So this time I'm looking for a side again, but I could say, let's see, JL is opposite K, which is the sine of 20. So the sine of 20 over JL is equal to the sine of 140 over 9. I only have one variable because JL is just the side. So yes, I could solve it. So yay. So notice, when I had two sides, and then an adjacent angle, I could do it. When I have two adjacent angles and an adjacent side to that, I can do it. But when I have, in this case, two sides and the included angle, I can't. Let's look at our fourth option. So in this case, I only have all three sides. And here's the problem. When I write it out, all the sides have variables. So I can't use any of these. So I can't use that. So notice, if I'm only given one angle and it's the included angle, or if I'm only given all sides, I cannot use the law of sines. So the question I know all of you are asking now is, what do we do when we can't use the law of sines? And the answer to that is we use the law of cosines. Now, here we have the exact same image we've been using before, but let's just talk about it. So for any side or any angle, we can use a variation on the Pythagorean theorem that takes into account that it's no longer a 90-degree angle. And so if we wanted to find, for instance, a squared is equal to b squared plus c squared minus 2bc cosine a. So you do basically Pythagorean theorem minus 2 times the other two sides times the cosine of that angle. The same rule applies for b and c. B is equal to a squared plus c squared minus 2ac cosine b, and c squared is equal to a squared plus b squared minus 2ab cosine c. It's just plugging it in. Now you might be like, Mr. Peacock, this seems very difficult. Will you please show us how to do this? And my answer to that is no, because that would make this video longer. And I don't want to. And I actually don't have to teach this class anymore, so I'm not gonna. That's not the point of Geometry Bites. The point of Geometry Bites is that you like and subscribe. Thank you all very much. Have a wonderful day. There will be more of these videos, probably with things that don't confuse you there at the end, coming up soon. And then I'll have to figure out something else to do with this channel because it's not going to still be math. I mean, I'll still have the math up, but it won't be math. What am I going to do? Bye, everybody. Bye.